Welcome to FM Tuition Academy. Okay, so if it's your first time, make sure you subscribe. There's a button there down written subscribe. Click the subscribe button for those ones who haven't subscribed. Those ones who have subscribed, there's no need. So if you haven't subscribed the channel, make sure you subscribe. Okay, now we are going to be learning about laws of motion. Laws of motion. To be more specific, Newton's laws of motion. Okay, Newton's laws of motion. So there are three laws. There are three laws, okay, of motion. So there are three laws of motion. There are three Newton's laws of motion. So Newton, there was a scientist by the name of Newton, Sir Isaac Newton. So Sir Isaac Newton was a scientist. So he came up with three laws. Okay, they are the ones that you use in physics. So I'm not going to enter into those details because I want to teach you the strategies on how you can pass your exam. Just know there was a scientist by the name of Newton. So he came up with these laws. So the first law of motion that Newton came up with. So what Newton said is an object. You have to know these ones by heart because they can ask you in the exam, state Newton's law of motion. State Newton's first law of motion. You should know it by heart. An object at rest or in motion remains in that state unless an external force acts on it. So Newton's first law states that an object at rest or in motion will remain in that state unless an external force acts on it. What that means is, for example, if you leave your phone on the floor, it is at rest. Okay? If you leave your phone on the floor, this is a phone, for example. This is a phone. If you leave it on the floor, this is a phone. You have left it on the floor. It will remain here on the floor unless an external force moves it from where it is positioned. So that's what Newton said. He said an object at rest. If you leave an object at rest, it will remain there unless an external force acts on it. Okay? If you leave your shoes in the house, they will remain there until an external force acts on it. Okay? So wherever you're leaving an object, it will remain there unless an external force acts on it. So that's what he said, that an object at rest or in motion will remain in that state unless an external force acts on it. For example, when you kick a ball, or when you have a ball on top of the mountain, you leave the ball on top of the mountain. If this is a mountain, for example, this is a mountain, okay? And then you are with a ball. That ball continue coming down, rolling down, rolling down, rolling down, until someone stops it. There's an external force stopping it. Okay? It will continue coming down. So this is just a simple illustration. An object at rest, okay, at rest, will remain at rest. Or in motion, this is an object on top, like a ball. It's rolling down, rolling down. It will continue coming down until an external force acts on it. So an object at rest or in motion will remain in that state. It will continue coming down unless an external force acts on it. So that's what I've said, that an object at rest or in motion will remain or remains in that state unless an external force acts on it. Unless an external force acts on it. That's the first law of motion. Newton's second law of motion. Second law. It states that the force applied on an object produces an acceleration. The force applied on an object produces an acceleration that is direct proportion to it. Okay? The force applied on an object produces an acceleration that is direct proportion to it, but inversely proportion to the mass. But inversely proportion to the mass. Okay? So in short, force is direct proportion to acceleration, but inversely proportion to the mass. So the force that you apply on an object, so this states that the force applied on an object, okay, the force applied on an object produces an acceleration that is direct proportion to it, but inversely proportion to the mass. Okay? So it means if this is the object, when you apply force to it, this is force. You have applied the force, okay, on it. You are pushing it this side, this direction. So this is a road. This has got wheels. So it will start moving in this direction. So that movement in this is what's called, this is what acceleration is. It will produce an acceleration. Okay? So this vehicle start accelerating. Accelerating means it's moving. Okay? So the force applied on this object will produce an acceleration. In short, force applied on an object will produce an acceleration on that object. And that acceleration is direct proportion to the force. This force and the acceleration, they are direct proportion. Okay? But inversely proportion to the mass. Okay? So for example, if you're on the table, you put a box on the table. Okay? And then you push that box. Okay? When you push the box will accelerate, it will move. So it means the force that you're applying is direct proportion to the acceleration that is causing the box to move, but inversely proportion to the mass. Okay? So you should know that by heart. That force applied on an object is direct proportion to the acceleration. Force applied, you should know this by heart. By heart, the force applied on an object produces an acceleration that is direct proportion to its, that is direct proportion to it. That is direct proportion to it. Okay? But inversely proportion to the what? To the mass. but inversely proportional to the mass. But inversely proportional to the mass. So force applied, Newton's second law states that the force applied on an object produces an acceleration that is direct proportion to it, but inversely proportion to the mass. Okay, lastly, Newton's third law. It states that the law of action reaction states that for every action there is an equal and opposite reaction. That's what it states. The law of action reaction. So when you're setting the third law, you say the law of action reaction states that for every action there's an equal and opposite reaction. For example, if this is a wall, okay? If this is a wall and then you punch this wall with your hand, you punch it. When you punch this wall with your hand, the wall will punch you back with the same force. Okay? If you are punching this wall with 3 newtons, the same wall again will punch you back again with 3 newtons. That's the reason why when you are punching a wall with your hand, you feel the pain. If you punch a wall with your hand, you find that your hand will feel pain. Why? Because the wall also punched you back with the same newtons you punched it. It reacted back. So the law of action reaction states that for every action that you are doing, there's an equal and opposite reaction. There's an equal and opposite reaction. Okay? It states that the law of action reaction states that for every action, there is an equal and opposite reaction. Okay? There is an equal and opposite reaction. So those are the laws of motion. And then you have to know certain definitions like weight. What is weight? Weight, it is a gravitational pull on an object. Weight is the gravitational pull. Gravitational pull exerted on an object, meaning the earth is involved, it's pulling you down. The weight is a gravitational pull exerted on an object. So you should know what weight is. Okay? And the formula for weight is equal to, they can also define weight. Weight is a gravitational pull exerted on an object. Weight is equal to mass times gravity. So M, it means weight. Okay? And weight is measured in what? In newtons. Okay? Newtons abbreviated as N. That is a symbol, N. Okay? That is M. So that is M in the equation. And then there is also, W in the equation. W means weight, which is measured in what? Newtons, with a symbol N. And then M is mass. M is mass. Okay? Measured in what? measured in kgs. So it means whenever you're doing physics, your calculations for mass should always be in kgs, always be in kgs. And then G means gravity. They usually give you, it is either 9.81 or it is 10 meters per second squared. So it's either 9.81 or 10. They'll tell you in the question. If they haven't told you, use 9.81. But if they've told you use 10, then use 10. If they haven't said, use 9.81. Okay? They'll tell you in the question. If they haven't specified, then use 9.81. If they have said use 10, use 10. They can say G10, then use 10. They can say G 9.81, use 9.81. And then there's such a thing as force. What is force? Force is a pull or push on an object. Force, it is a pull or push exerted on an object. It means you are pushing an object. Huh? You see when you are pushing your friend, you are applying force. Or when you are pulling your friend, say, come here. That is what force is. So, the formula for force is equal to mass times acceleration. So, F means force, which is measured in newtons. You see, N. You remember I said weight is also measured in newtons. So, this is N. I have to just put my brackets like that, abbreviations. So, force and weight, they have the same unit. I repeat, force and weight have the same unit because weight is also a force. Okay? M, you already know. M, I said, is mass. I will not tell you because you already know now. M is mass, which is measured in kgs. You already know that. A means acceleration. A means acceleration, guys. Okay? Acceleration, which is meters per second squared. Now, the difference between force and weight. I said weight deals with gravity. You remember what I said? Weight deals with gravity. You have seen the formula for weight. It deals with gravity here at the end. Here there is G. Weight is mass times gravity. This gravity is acceleration due to gravity. mg. G means gravity. Okay? But with force, the G is A. Okay? With force, where there is G, it's A. So it's just normal acceleration. This one is A, which means acceleration. Okay? Just normal acceleration. A means acceleration. But G means acceleration due to gravity. G means gravity. So it means acceleration caused by gravity. But A is just acceleration. Okay? It's not acceleration by gravity. It's just normal acceleration. Okay, guys. Okay? Now, they can ask a question. I'll say example 1. And you already know, you guys, even the formula for acceleration. Before I do example 1, you already know that we said force is equal to mass times acceleration. Okay? So, this formula can also be written like this. Sometimes, if the acceleration is not given, the formula can be written like this. Force is equal to, what's the formula for acceleration? Final velocity minus initial velocity over time, close bracket. That's the other way how you can write this. Because this acceleration is final velocity minus initial velocity over time. I taught you this in an equation of motion. So where there is A here, I put brackets and then I put V capital minus U over T, because acceleration is final velocity minus initial velocity over time. So this formula and this formula, they are same. Depending with a question, if they give you a question that has got velocities, then use this one. Okay? Use this one. if the question has got velocities, meaning you have to use this one. If the question doesn't have velocities, it has acceleration, you use this one. If the question has got velocities, you use this one. You use this formula. You have to know this formula by heart because it's final velocity, initial velocity over time. Okay, you understand? For example, if they give you a question like example 1, they can say a bicycle with 2 kg mass moves from 2 meters per second to 6 meters per second in 0.5 seconds. Calculate the force. Have you seen this question? Before I even do anything, I already know that the question has got velocities. Okay? So I'm doing with solution now. The question has got velocities, meaning the formula that will work here is that one with velocities, because this is solution. So if you look at the question, it has got velocities, guys. So it means because of the velocities, you have to use that other question. Have you seen? There is this velocity here. It started with 2 and then it went to 6, so it increased. Okay, from 2 to 6. Sometimes it can reduce. So meaning it's the first velocity, and then this one is the second velocity. Okay, so meaning the formula we use for force should have velocities. So force is equal to mass times acceleration. And then when I write this formula, I substitute where there is acceleration there, I put v minus u over t. I've explained this, which is equal to, what is my mass? My mass is what? This object was how? Is 2 kgs. Have you seen? 2 kgs. If it was in grams, you convert by dividing by 100, because the SI unit for mass is kgs. So 2 kgs mass, so mass is 2 kgs. So where there is mass there, I put how many kgs? So here where there is mass, I put 2 kgs over final velocity. Final. There are 2 velocities in the equation. So this is the first velocity. This is the second velocity. So the second velocity is the final. Okay, you are from 2, you are going to 6. 2 to 6. So it means you started from 2, you went to 6. So meaning final is 6. Initial is 2 here. Final is 6. Initial is 2. So I go there, I come where? Here. So final it is 6 minus initial it's 2. Over, we took how many time is what? Over what? We took how many seconds? 0.5 seconds. The time was given to 0.5. Don't say, where is the 0.5 coming from? It's here. 0.5 seconds is here. To move from 2 to 6, you take 0.5 seconds. Only that 6 is final. And then you calculate that using a calculator. That's not a big deal. So it is 2 open bracket 6 minus 2 over 0.5. So you are punching this on the calculator. So when you punch this, you start with the, you punch on the calculator. What is 6 minus 2? 6 minus 2 is 4. You put 4 there. Over 0.5. Any number on its own is over 1. Okay, this 2 times this 4 on top. 2, any number on its own is over 1. So 2 times 4, 8. Over 1 times 0.5, it is 0.5. Then you divide that. 8 divided by 0.5. You have calculators, guys. I don't need to teach you this. You already know how to divide using your own calculators. Okay? 8 divided by 0.5. What answer do you get? It is 16. So 16, since it is force, it's 16 newtons. Okay? 16 newtons. There's no space down, but you when you're solving, follow down. So it means 16 newtons is the answer. Okay? Okay, so sometimes they can say a book or a box weighs 25 grams and moves from rest to 36 meters per second in 2 minutes. Find the force. You see this question, the way I phrased it, huh? Find the force. So because of the velocity, so use the velocity formula. I told you, whenever I say velocity, use the velocity formula. Let's see if the velocities are not there. So velocity is force is equal to mass times acceleration. So mass times acceleration is final velocity minus initial velocity over time closed. What is the mass? You remember I said the mass should always be in kgs. So you come. They said 25 grams. Do you use 25 grams? No. I told you that mass always has to be in kg. So you convert the mass. So you already know that 1 kg is equal to 1000. So 1 kg is equal to 1000 grams. Okay? How many kgs are equal to 25 grams? So you convert 25 grams to, so you cross multiply that. So it will give you 1000x is equal to 25. You divide both sides by 1000. I think you know this. By 1000. I'm just doing it to help you. So meaning x is going to be equal to 25 divided by 1000 is 0.25. Okay? So you don't use 25 grams because the SI unit for mass is kg. So you convert the 25, so it will be 0.25 kgs. Okay? So that's one I'll use here. So on mass here I put 0.25. Open bracket. Final velocity. What is my final velocity? So it is from rest. Okay? It's from rest to, so meaning this is the first velocity. From rest, it means initial velocity here is 0. Okay? If they said from rest, no, they didn't say came to rest. They said from rest. And then here, this other velocity will be final. Because it's from rest to this one. So it means final velocity there, it's 36. Initial velocity is 0. So I'll come there. Final velocity, it's 36. Minus initial velocity is 0. Okay? Over time. Time is what? 2 minutes. You already know how to do the conversion. 2 minutes. We don't work with minutes. We work with seconds. You already know how to convert minutes to seconds, guys. How to convert minutes to seconds. 2 minutes into seconds is 120 seconds. I don't need to teach you this. 2 minutes. Maybe I do the calculation for 2 minutes. You already know that 1 minute is equal to 60 seconds. So 2 minutes is equal to x. You have done this. This is grade 9 maths. So 2 times 60 is 120 seconds. That's why I got the 120 here. Don't say where is 120 coming from. No. You convert the 2 minutes to seconds. And then you simplify that. So we have got 0.25 open bracket. We've got 36 minus 0 over 120. So 0.25, 36 minus 0, it is 36 on top over 120. Any number on its own is over 1. So 0.25 times 36 there. 0.25 times 36. What's the answer? 0.25 there. 0.25 by 36. 0.25 by 36 0.25 by 36 is 9. Okay, 9 over 1 times 120 is 120. Okay, and then what is 9 divided by 120? When you divide 9 by 120, what do you get? 9, you divide it by 120. You get 0.075. Okay, newtons. Okay, 0.075. That's the answer. That's how you solve such kind of questions. You need to be very careful when you are doing this. Okay? Okay. Sometimes that was example 2. I can bring example 3. Sometimes I can bring for you a box like this. Have you seen? And then they can give you a weight this side and another force this side. This is a box on the table. They can say this is 6 newtons. And then they say this is 6 newtons. And then they say this is, for example, they can say 9 newtons. And then they say the mass of the box is, they can say the mass of the box is, for example, 10 kgs. Okay? And then the first question they can ask you is, 1, calculate the resultant force. Calculate the resultant force. Okay? How do you calculate the resultant force? You see, it's like there are two people. These guys are pulling with 60 newtons this side. Have you seen? Others are pulling this side at 9 newtons. Others are pulling the other side at 6 newtons. So meaning the resultant is a subtraction of these forces. So it's 9 minus 6. Okay? The resultant is 9 minus 6. You just subtract the smaller, the larger number from the smaller one. So 9 is larger, so minus 6. So meaning the resultant there, it is resultant force is equal to 9 newtons minus 6 newtons, which is equal to 3 newtons. That's how you find the resultant force. You subtract since there are these guys pulling with 9 newtons, the other side they are pulling with 6 newtons. So you just have to subtract. You see? So the second question from the same one, question B, they can say calculate the acceleration. Okay? They can say calculate the what? They can say calculate the acceleration. So for you to calculate the acceleration, you have to know, looking at that board, you use the formula force is equal to mass times acceleration. Since I want you to calculate the acceleration, you make acceleration the subject. Okay? So I'll rewrite it. I'll put mass times acceleration in front, and then F will go this side. I want to make acceleration the subject. I divide by m. I think I've taught you this, by m. So you remove this, you remove this. So the formula for acceleration is equal to force over mass. That's the formula we use. Force over mass. So acceleration is equal to force over mass. So acceleration is equal to force that is there over the mass. You remember the force, we already calculated it. The force that we're going to use is the what? Since there are two forces that were acting on that box, but we use the resultant force. We're trying to find the acceleration, so we use 3. That's the force that we use. So 3 will be the force. So force is 3. On force you put 3 over the mass. What is the mass that is there? The mass was given in the question. The mass was what? 10 kgs. Since it's in kgs already, you don't need to convert. So where there is mass there, you put 10. So divided by 10, which would be 0.3 divided by 10 is 0.3 meters per second squared. Have you seen the way I've done it? So sometimes they can ask to calculate acceleration. Okay? Acceleration. And how did we calculate acceleration? We use the formula for force. So why did I use the formula for force? Because of those two forces they gave us. You remember? They gave us two forces, and then we calculated the resultant force. So in calculating the acceleration, you use the formula for force, but you make the acceleration the subject. That's how you do it, guys. That's how you do it. Okay? That is example, is it 3? Now example 4. Sometimes they can give you now, for example, you're dealing with forces, you're now going to deal with weight now. They can say a mango, they can say a mango weighs 2 kgs. Calculate its weight. Okay? So you should know. Whenever dealing with weight, you are dealing with gravity. I told you. So it means weight is equal to mass times gravity. So weight is equal to mass times gravity. So what is a mass? 2 kgs. You put 2 times gravity. It's 9.81. If they haven't given you, you use 9.81. Sometimes they tell you gravity is 9. They can say 10. Okay. So here is take G to be equal to 10 Newton per meter squared. So meaning that's a gravity. That's why I've used it. Taking G to be, okay, here I'll use 10. Let's say take G to be 10. So it means in the question they said a mango weighs 2 kgs, calculate its weight. Take G, that's a question. Take G to be 10 point, take G to be equal to 10 Newton per meter squared. They can say meter squared or what, but they just say G. So you should know what they're meaning. Just take this 10, you put this side. If it's 9.81, that's one you put this side. So it will be what? 20 newtons, because weight is measured in newtons. That's how you do this. So they can give you any weight. That's how you do it. Okay? And one of the things you know about weight, guys, weight does not change. Okay? Weight changes, but mass is always constant. I repeat, weight does not change. Weight changes, sorry. This is just notes. Weight changes, but mass is always constant. So if you have got a mass of 2 kgs on Earth, okay, this is on Earth, okay, you will be also 2 kgs when we take you to the moon, okay, but your weight will change. Your weight, okay, I said this is mass. Mass is always same. This mass on Earth and also the mass on the moon, they are same. Mass on Earth and mass on the moon. I've already explained this. Okay? Weight changes, but mass does not change. Where was that? I lost that page. Weight changes, but mass is always constant. So I said, let me write what I wrote. I've lost that page. There's a page I've lost. I'll write it again. So I'll write a new one. So I said, weight does not change. So I'll say mass on moon, for example, and also mass on Earth. So if you are 2 kgs on the moon, okay, on the moon if you are 2 kgs, meaning on Earth also you'll be 2 kgs, because mass does not change, okay, but the weight will change. The weight will change because of the gravitational pulls that are different. Weight changes, okay. Mass does not change, weight changes. mass does not change, weight changes. So if your gravitational pull here on the moon, if it's smaller, your weight will be small. Here on Earth, the gravity is big, it's 10, the weight will change. But your mass will not change. I repeat, even in the question, if they ask you, calculate, if they tell you a person was weighing this amount, for example, you have to be very careful, because they can ask you even in example. I'll bring an example 5. They can say a man weighs 4 kgs on moon, okay, and is brought to Earth. Where the gravity is 9.81. Calculate his mass. Okay. So you don't need to calculate anything. Just by looking at it, you already know that weight, mass, they're saying calculate his mass. Calculate his mass. We said mass is always constant, whether you're on the moon, on Earth. So I don't need to calculate anything. I just see, oh, the mass on the Earth on the moon is 4 kgs, meaning also on Earth is 4 kgs. Even if they have given you this gravity thing, you don't use it. It's just there to distract you. So you say the answer there is the mass is also what? Is also what? The mass is also what? 4 kgs. The mass is also 4 kgs. So I said the mass is also 4 kgs. You see? That was the mass that was there. So the mass doesn't change. So that's how you calculate. Okay? Let me give you an exercise now. So try to do this exercise. I hope you have got some understanding. Question 1. Question 1 states that a boy moves from 2 meters per second to 12 meters per second in 0.3 seconds. Calculate the force. Okay? Question 2. A box on the table at rest moves to 13 meters per second in 4 minutes. Calculate the force. Calculate the force. Question 3, they have given you a table like this. Okay, this side is the 12 newtons. They have given you this side is 0. No, this side is 9 point. That side is 3 newtons. Okay, the box is 40 grams. You see, I've put grams, so it means this one is supposed to be converted. I've explained this. This is supposed to be converted. A boy moves the there's something I left. A boy of mass. A boy of mass. They're supposed to read a boy of mass 0.4 kg moves, okay, from 2 meters to 12 meters. I left this. Supposed to read a boy of, this is the first question. I'm correcting the first question. A boy of mass 0.4 kgs moves from 2 to 12 in 12 seconds. That's the way the first question was supposed to read. And then the second question also, I forgot the mass, so I'm writing it. A box of mass 5 kg. A boy of mass 5 kg moves on table at rest. Let me see, a box of mass 5 kg. I didn't construct this well. A box of mass 5 kg on the table. On the table a box of mass 5 kgs on the table moves. It was supposed to read moves from rest to 13 meters per second. That's how it's supposed to read. I've corrected these questions, so you have to correct them so that you do the correct thing. So a box of mass 5 kg on the table, this is question 2, moves from rest. You know what it means when they say from rest, to 13 meters per second in 4 minutes. Calculate the force. Okay, so we can go now to question 3. Let me finish with question 3. Okay, this is the way the question 3 is. Okay, so question 3a, I corrected question 1 and 2. This is question 3. I'm proceeding with question 3. I didn't finish. I remember the mistake we made from question 1 and 2. Question 3, so is calculate the resultant. Calculate the resultant force. Calculate the resultant force. That is A. B. Calculate the acceleration. I showed you how to do this, but you have to make sure the mass is converted to kgs. I showed you how to do that. Okay, so we end here. Do that exercise. Thank you.